Today we're doing section 2.5, day 1, and we're going to discuss how to find the zeros of polynomials. So first we're going to discuss how to find your list of possible zeros. So you take all the factors of the constant term and divide it by your factors of the leading coefficient. So the reason I put plus or minus in front, obviously, like if you have the number 2, a positive 1 and a positive 2 make 2, but a negative 1 and a negative 2 make 2. So you just put a plus or minus, and that takes care of all of your scenarios. So let's just practice making our list of possible zeros. So here is our constant term. So my factors of 6 are 1, 2, 3, and 6. Over my leading coefficient of 1. So obviously dividing by plus or minus 1 is not going to change my list at all. So my list would just be the 1, 2, 3, and 6. For the next one. All right, there we go. Sorry, I got a little ahead of myself. So for the next one, we make our list of possible zeros. So we would do our constant term, which is 3. So the factors of 3 are 1 and 3. Over a 1 again. So again, the list would just be 1 and 3. And what this means is you have 4 possible numbers that could be a 0. So let's show you how you apply this skill. So the directions want you to solve. So we would start by making our list of possible zeros. So I have 24. So I have 1, 2, 3, 4, 6, 8, 12, and 20. And I'm dividing it by plus or minus 1, so I don't need to put that. It's not going to change my list at all. So of all of these numbers, some will be potential zeros. So the way you have to do this is you plug them in. So you would use your calculator, you're going to plug them in, and you're looking for the one that gives you an output of 0, because that indicates you have no remainder. So for the sake of time, I'm just going to tell you that when you evaluate the function of 2, you get the output of 0, which means that's a 0, so we can proceed with synthetic division. So I have 1, 0, negative 6, negative 8, and 24. I drop this, I get 2, I get 4, negative 4, and a negative 24 here, so I get the no remainder that I needed. So by doing this, I've scaled it down, so now down to the third power. So this is x to the third plus 2x squared minus 2x minus 12. So again, we would make our list of possible zeros. So now it's with 12, so it's 1, 2, 3, 4. Oops, too many 4s. 6 and 12. So notice my list is a little bit smaller to work with. Again, we're going to plug them in, and we're looking for the one that gives us 0. Again, for the sake of time, I'm just going to tell you that 2 is going to work again. So 2 is the value that we're going to do synthetic with. That will not always be the case. So we're going to do 2, and we're using the new set of numbers. So you don't want to go back to the original. You want to keep scaling it down. So I've dropped the 1, I multiply, I get 2, this is 4, 8, 6, and 12. So now I'm at x squared plus 4x plus 6. And now that I'm down to the second power, I can do quadratic formula to solve, and that's what we're going to do. I just need to give myself some more room. So we're going to do quadratic formula. You could obviously check to see if it's factorable. Nothing's going to multiply to be 6 and add to be 4. So quadratic formula, we have 4 squared minus 4 times a times c all over 2a. So I have 16 minus 24. We get negative 8, which will be a 2i root 2. So I have negative 4 plus or minus 2i root 2 all over 2. I can reduce the outside numbers, so I'll get negative 2 plus or minus I root 2. So these are our 2 imaginary answers, and then the 2 real answers that we got were from the synthetic part, And here would be the 4 answers that we knew we were supposed to get based on the highest exponent. Just to kind of tie things in, if you needed a visual, I got 2 with a multiplicity of 2. So that means there's going to be a turnaround happening on the x-axis at the value of 2. And then it's not going to touch the x-axis again because the other 2 values are imaginary. So let's try one more. So this one's not as involved because it's kind of already factored for you. So for this part, I'll get the answer of 2 again, but I get this answer of 2 times. And then the other part is the same as what we did, so we know that answer is -2 plus or minus I root 2. And I'm looking at this, and I think this is the same exact problem, just written in different forms. So I'm not really sure why I put this problem on here, but oh well. All right, have a good day.